Okay, everybody. So what are we looking at? A black screen? Let me fix that. Hold on. All right. So get rid of this. So yeah, so we're going to be talking about programming homework for today. Right. So um, this is your last programming assignment. You do need to do this. It has a question in here, or rather, the whole assignment in here is part of the SLO assessment for this class. And so, if a lot of you don't do it, then that will be bad for me. So, hopefully, everybody will do this. It's not, a super tough assignment, but here we go. So, what is programming for? So, in programming number 4, what you're going to do is you're going to make MATLAB or Octave play Tic Tac Toe. Now, we're going to have a very simple game here. We're not going to do graphics. We're not going to open extra windows and stuff like that. You could do that in MATLAB. MATLAB does have some like GUI stuff that you could use to actually make a game that looked like a game. But it's just more than what we want to try to do in this class, right? This class is more about numbers and stuff. So yeah, we're not going to concentrate on prettying all this stuff up. Okay, so this is what we're going to do. Now, why are we doing it? So the reason we're doing this is because basically you can think of tic-tac-toe as having well, not several, well, two basically finite state machines in there. Basically, I'm going to write this. Um, there are a couple, I can't type, of finite state machines in tic-tac-toe, right? So where are they? Well, something I've noticed too in this class from the last time is that actually not everybody knows what tic-tac-toe is. So let's just make sure that we agree what tic-tac-toe is. So here's tic-tac-toe. Start game. Restart game. Okay, this is it. So um, tic-tac-toe, if you're not aware, you have a little 3x3 grid like this. One player is X's, one player is O's, and you take turns putting an X if you're the X player, or an O if you're the O player in one of these 9 spots, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different spots. So if I'm the first player, I can start by putting an X wherever I want. I'll put it here. Now then O makes a turn. They could put an O anywhere. They already did. They put an O here. Now my turn. I can put an X anywhere. And what am I trying to do? Well, what you're trying to do in tic-tac-toe is you're trying to get 3 of your symbol in a row. So I'm trying to get 3 X's. So where could I put an X that I might be able to get 3 X's? I'll put one here. So you see that I had 2 X's in a row. So the computer put an O right here. It blocked me. Now I won't be able to get 3 in a row diagonally. So what can I do now? Well, I can put an X here. So the computer decided to block me here because I had 2 in a row. So they put an O here to stop me from getting 3 in a row, but they left me open. So now I can put an X in this spot right here, and I'll have X, 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 and I'll win the game. So I'll click here, and I've won. So that's tic-tac-toe. So it's a pretty simple game. There's strategy for it. You can look it up if you care. So they got 2 in a row, so I got to put an X here. Now they've got 2 in a row, so I have to put an X here. They have 2 in a row, so I have to put an X here. And this is how games usually end. You usually get a draw once somebody is, sorry, emergency alert on my phone here. So tic-tac-toe usually ends in a draw if people know what they're doing. So very simple game. What can I say about it? There was something I wanted to say. Yeah, so just to be 100% clear, 3 in a row for either X or for O win the game. So 3 X's horizontally, 3 X's vertically, or diagonally will win. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 winning conditions, basically. Uh, and that's tic tac toe. So I say that it's a finite state machine because basically, this game, like most games, what you have going on is that every state of a board, every state of the board, uh, I should say every configuration of the board, every configuration of the board in terms of X's and O's is a state, right? And that state can, transition with a state transition to other states. Not every other state, but some. So, for example, here's how we're going to represent a tic-tac-toe game. We're just going to use a matrix for it. So when we start, our tic-tac-toe game is just going to be like this. It's just going to be 0, 0, 0, 0, 0, 0, 0, 0, 0, right? So this is going to be the starting state. Looks like this. Now, then what you're going to do is you, as the player, are going to make the first move. You're going to put an X somewhere. So after the first move, what will the board look like? Well, that's going to depend on where you put your X. So you could put your X right here, in which case this would be your first move, right? But that's not the only way you could have done it. You could also put an X over here, right? That's another valid move, right? So every valid move would be another possible state. So there's actually going to be 9 possible states that you could be in after the first move. So you start in one state. There's going to be 9 states that you could have for the first move. So there is one state for S, we'll say S0, right? Starting state. But then there are going to be there are 9 possible first moves. So that is 9 possible states you could be in after one move. Right? So 9 possible first moves, 9 possible states to be in after the first move. How many would there be for the second one? Well, just think about having a state like this. If the next player comes in, oh, sorry, by the way, I shouldn't have done this, but the way we're going to do this on the computer is internally we're going to use 1 instead of X, and we're going to use 2 instead of O. That way, when you look at a configuration here, the 1 is where player 1 went, the 2 is where player 2 went, and the zeros are open spots. That's how we're going to do it in MATLAB, where we're going to be using numbers. Okay, so zeros and ones and twos is what we're going to use, not X's and O's. So 9 possible states after the first move. Now, if you come here as player 2 and you say, well, where can I put a 2 in one of these states, right? Well, you can't put it where there's already a 1. So there'd be 8 possible moves for player 2, right? So 8 possible moves for player 2. Oops, typing hard. For player 2. 8 possible moves for player 2. Now you might look there and think, like, okay, well, if there's 9 states for player 1 after one move, and then 8 after player 2, then that would be 17 states. But that is not true, because actually you have your S0, which is one state. I'm going to ignore that S0 for now. But there's 9 possible states to be in after one move. And then each of those 9 has 8. So far, that is, there's 9 states that you could be in after state 1. And then you also have 8 possible moves for player 2. So that would actually be 72 states after 2 moves that you might be in. So there's 72. And then there's going to be, after another move, right? Once you have a 2 in there, right? So let's just take this. So like, let's say you have this, and then player 2 goes somewhere. They can go wherever they want. So like, let's just say that they go right. Let's just say they go right here, right? Then now you've made 2 moves, and there's 7 open spots for the third move. So hopefully you can see that the total number of states, if you count them up this way, is 9 times 8 times 7 for after 3 moves. But then there's going to be 6 possible moves for the next time, 5 possible moves for the move after that, 4, and then 3, and then 2, and then 1, right? So that's actually a pretty huge number. That's 9 factorial. And that's not counting the starting state. That's not counting the starting state. But there's that. So I guess if I put a 1 in there, plus 1, would be the total number of states that the board could possibly be in. And that's a lot of states. They're not actually all valid though, because you could never get a configuration like this. Like you couldn't ever have like a 2, 2, 2, and then I guess if 2's made 3 moves, then 1 must have made 4 moves, or like you could never have this. This is never actually a possible state for the game. Or maybe it is. Hold on, let me change something. This would not be allowed a possible state for the game. There's no way that player 1 could have had 3 in a row and player 2 had 3 in a row, because the game would have already ended. Like, so when one of the players got 1, 1, 1 or 2, 2, 2, the game's over. And so, the game doesn't continue. So these are not all valid states, but these are all, there's this many states that, could potentially exist on this 3x3 board. Okay. They're not all valid. So the reason I'm just saying that is because most states or rather, you can't list every state. I mean, I guess technically you could, right? S0, S1, S2, ... because it would be way too many to do. Right out. But technically, it is a state machine. Okay? So the board configuration is states, which is what I set up here. But that's not the only state machine technically, because also the game logic could be presented as a state as well. So you could also say, so the game logic could also be seen as a state machine. Right? Because what you have is just, well, I mean, we're not going to do it this way, but you could have something like this, right? Like when you start up, you have a like S0 could be waiting for player 1 input, um, or get player one input, and then S1 could be like, well, what did it have to do? So you have to get player one input. You have to update the move like that. Um, you have to check if there's a win. I'll call that S2. Um, player wins. Um, then you're going to have to, um, have the computer make a move. And after you do that, then you need to check if a player won. You don't need like S4, check if the CPU won, because um, you could just use S2 for that. Um, so yeah, so you need to get input, get player one, update the board, check if players won, have CPU make a move, and and then you could have, I guess, you know, game over or something state. And so by changing between these states, um, I guess I should stay with the new move. That way we could use the same state for CPU and players. So yeah, so you've got players making moves, CPU making moves, updating the board, checking if players won, and then just what you do when there is a game over. And then the game logic could be how you change from one state here to another state here. Okay, but we're not going to actually like enumerate these states and do it that way. We're just gonna code up tic-tac-toe, okay? And I realize that some of you are doing a tic-tac-toe game in your other classes, in which case ours is probably going to be simplified compared to what you see in your other classes. This isn't really like a full-on programming class, and MATLAB is not really a full-on programming language for this type of thing. I just thought it's a simple thing to code up for us. So we're going to. So with that said, let's go ahead and look at um, the actual assignment itself. All right. So first of all, like I said, let's go octave. Like I said, the board is going to be stored just as a matrix. So like when we start, our board's going to look like this, just 0, 0, 0, 0, 0, 0. Now, when we update a move, we are just going to we're just going to put a 1 in the spot, like I said. So when we update a move, right? Like let's say, suppose the player, this is not going to, this is going to give me an error because I'm typing words at the command prompt here. But suppose the player wants to move to spot, I'm going to say spot 3. Error. Suppose the player wants to move to spot 3. All you're going to have to do is you're just going to put a 1 in spot 3. Now, so you'll just do that kind of thing. Okay. Now we're going to do it in code, not just here at the command prompt, but that's what we'll do. Now, the reason I'm doing this right now is I want to point out where A3 is. It's down here in this corner. The way that the numbering is by default, and it's not worth working around, is that upper left is spot 1, then 2, then 3, 4, 5, 6, 7, 8, 9. Now, if it was up to me, that's not how it would be, right? Like I would prefer this. I would prefer that the board was like this. 1, 2, 3, whoa, 4, 5, 6. Stop that. I command that you stop that. 7, 8, 9. That's how I would like it, but it's not like this. It's not 1, 2, 3 across the top. Okay, it is 1, 4, I guess 7. Why does it keep doing that? 2, 5, 8. I hit enter and it tries to guess at what's going on. This is the way it's numbered. Okay, so unfortunately that's how it is. But just be aware of that 1, 2, 3 going down, 4, 5, 6 going down, 7, 8, 9 going down. So when you pick a move, it's going to ask you to pick a move by number, and that's how we're going to do it. Yeah, how we're going to do it. Okay, so that's all we're doing. So when the player makes a move, you just put a 1 in the right spot in the board, and when player 2 makes a move, you're just going to put a 2 in the spot on the board. And obviously you can't overwrite other people's moves, so I would not be allowed to put a 2 where that 1 already is. I would have to put a 2 in one of the blank spots. So I could put it in like 5. No, I couldn't, because that's how you would do that. Okay, so like you could do that. So you're just going to put 1s and 2s in here until somebody wins. Okay, now not at the command prompt. You've got all these functions here. So what do the functions do, right? And you need to kind of figure this out, but we'll figure it out. So the first one that you need to look at is going to be player move and player test. Okay, so player move, let's open that. So what player move is supposed to do is this. So the input to player move is a board. A board is a 3x3 matrix, right? So the idea is you're going to have a variable like this. You don't make one. It's already, it's going to be set up, but the board starts out a 3x3 matrix. And then what you're supposed to be able to do is if I want to move, like let's say player 1 wants to move to a 1 or wants to move to spot 3. What I'm supposed to be able to do is type in player move like 3. No, sorry. Board, comma 3. I think that's what we have here. Oh no, we're not. We just are supposed to run player move board. I lied. Sorry. We're just supposed to run this player move board. And when we run player move board, it's going to ask us what move we want to make. And we need to, just provide a number 1 through 9. Okay. Now it doesn't work right now. If I run this, it just sits here. Okay. It's not doing anything. Another thing that's important is that you understand how to stop the execution of a script that's not running. So if you're on a PC, you'll hit Control C when it's running like this. See, we don't have a command prompt. If I hit Control C, I'm back to a command prompt that stopped the running thing. Now it didn't finish. It didn't finish because I didn't write it. Okay, so all of this stuff here, this code is already pre-written for you. All you've got to do is fill in line 11 here, which actually we're about to do, so it will be filled in. So let's just go over the code. We start out, move is -1. Sorry, I'm just double checking that this is actually running. Okay, so move is -1. What I'm doing is -1 is an invalid move. And so I'm saying that, that's just an invalid move. I'm setting it to not 1 or 2. Now I'm going to keep track of whether or not a move is valid. So I have a variable called move valid, and it's going to basically, this code is going to keep asking you for a move until you tell me a valid move, right? You're not allowed to pick a spot that somebody else already picked. You're not allowed to, pick below 0 or above 9 because there's only 1 through 9, that kind of thing. All right. And so there's a while loop here, while not move valid. So basically, while the move is invalid, all of this stuff keeps looping. So it keeps looping until you come up with a valid move, a legal move for the game. And when I run this code, it hangs because actually we're not even picking a move. So it's just doing this while loop over and over until a valid move shows up. Okay, so and then this is where how it checks. If the move is less than 1, not valid. If the move is greater than 9, not valid. If the move is not equal to the floor of move, not valid. What this is doing is just checking that you provided an integer. Um, and if the move is not valid, right? So we just need a way to get a move from the player. And we've never done this in this class, but you've done it in other classes. So MATLAB has a nice command for getting input from a player. So like, let's say I want you to choose a number x. Here's how you do it. X equals input, and then you just put a prompt here. Choose a number for x, colon space, right? So it's just a very simple line like this is how you can get input from a user. So if I hit enter here, you see what it does, choose a number for x, and command prompt. So I just pick a number, so like 9999, enter, right? And then it does x equals 9999, which you'll see it up here, 9999. All right, so that's all you have to do to get input from the player. Let's do that now. So how would I get this? What are we doing? We're getting a move from the player. And so the move started out -1. And so move is the variable for the move. So we just type move equals input, and then we just provide a prompt here. Pick a move, basically. So let's see. Choose a valid move, 1 through 9. Colon space. So that should be it. I'll put a semicolon on that. So that's all you have to do to make this player move work. So I'm going to save this. I've got an input line now. So now, where's my board? Okay, 0, 0, 0, 0. So if I, oops, VLC. So now if I run player move board, it should ask me for a move. And it does. It says choose a valid move 1 through 9. Okay, now I can pick a spot here, and if this code is working correctly, it should just put a 1 in the correct spot. So if I put like 7, then there you go. 1, 2, 3, 4, 5, 6, 7. So it put a 1 up in that upper right-hand corner. That was spot 7. Okay, now if I run this code again, actually I should do, so hold on here. The board did not actually update because the way I would do it is I would have to say board equals player move board. And if I run this, now if I pick a spot, let's pick 7 again, and it says board equals this. So this is the new board. Okay, so if I was going to have another turn here, I just have to run board equals player move board again. Now I need to choose a valid move. Now, if this right here is the current state of the matrix, then I would not be allowed to choose spot 7 again, right? That would be not allowed. So if I pick spot 7 here, it doesn't let me. It just asks me to choose a valid move. And if I pick a number bigger than 9, it doesn't let me. It asks me to choose a valid move. If I pick a decimal, it doesn't let me. It asks me to choose a valid move. So it's going to keep looping until I finally pick a spot that's actually allowed here. I have to pick one of the, like a spot where there's a 0, basically. So if I want spot, let's pick spot 2. Right? Then that works. Okay? So again, the only thing you had to write there was line 11, and we did, and now this works. So then what's going to happen is you should use the player test function. Now, this is not actually part of TicTacToe. This is just a function that I wrote that what it's supposed to do is it just lets you put in moves, basically. And it does that until you fill up the board. So like if I run player test, you can't run player test without a working player move, but player test, it just is going to let me pick moves. So like I can pick like 9, do it again, 1, 2, right? Every time I pick a move, it's filling in that spot. 4, 7, 5, 6. What's missing? 3. What's left? Just spot 8 here, right? Is that 8? I think that's 8. 8. And then it's done. Okay. So all this player test function is for is just it just loops through and makes sure that you can actually put something in every single spot in the board. Okay. And this is like a very simplified thing here, but it just goes until you fill up the board with ones. All right. And it's just a little function I wrote to test. Now, once you have that, you could actually run tic-tac-toe. Once your player move works, you can run the tic-tac-toe function. So here's the tic-tac-toe game logic. So what do? Step 1, we make a 3x3 matrix. Step 2, game is not over, so game over equals 0. Current player is 1. All right. So then we're going to, this is very typical for any kind of game. Once the game is running, it's just a while loop. So it just keeps doing turns until the game is over. So from line 5 to line 16 is a big loop for the basic game logic. Okay. While the game is not over, we're going to display the board. Display board is just going to draw the matrix on the screen. I made it a function because maybe you want to actually print out X's and O's on yours. And so you can fix that if you want. Print the board so you could play it. If the current player is player 1, that's you. You're player 1. Then you're going to do a move with player move, which we just wrote. And then the current player becomes number 2. Otherwise, then the CPU is going to make a move, and then the current player is going to be player 1. And that's it. So all this is going to do is if the current player is 1, the player makes a move, and then we set the current player to 2. If the current player is player 2, then the CPU is going to move, and then it's going to set the player back to the user. All right? And then we're just going to check if game is over. So there's a function that checks if the game is over. All right? So that's actually very simple logic for the game. And it'll run, actually. With what we have, with what I've written, it should run. Tic-tac-toe. Run. So it's not going to be a very good game, though. But this is how it works right now. So if I could take a spot. So what spot will I take? I'll take spot 1. I have a pause. What's going on? Why did it? Oh, okay. Yeah, so there's a couple things going on here. So told me game over is 0. That's weird. Where is game over equals 0? Oh, I want a semicolon on the end of this. I don't want that every time. Save. Let me start over. Go. Tic-tac-toe. All right. So let me pick again. I pick 1. Right. The game is not over yet. And this is what the current board is. Now this right here, board equals here, is what the CPU did. Also, this is bad too. I don't like that it printed out board like this. Let me fix that. That must be in the CPU move. Somewhere there's not a semicolon. Board. Yeah, there it is. That should have a semicolon. I'm going to zip this up and repost it. Also, these pauses are a little bit long. I just don't like it when the CPU appears to make a move instantly. Okay, try again. Maybe this is a little nicer looking. All right, choose a valid move. I pick one. Okay, it still did the same thing. I'm gonna have to put like semicolons on a lot of things here. Oh, I don't know. Well, whatever. There is somewhere where there's not a semicolon where there should be a semicolon, and that's why it's printing out the board twice. But I'm not going to worry about it at this moment in time. All right. So anyway, doesn't matter. This is the current state of the board. I went in this corner. The computer went here. So I pick a move. I can pick anywhere I want that's not already taken. So for example, I couldn't take spot 5, right? Because they are in spot 5. So if I try 5, it's just gonna tell me to make a valid move again. So I can go wherever I want. I'm gonna pick. Let's see here, 3. All right. So ignore the extra stuff. Here's where we are. They've got 2 in a row, so I need to go in spot 8 to block them. So I pick 8. They went up here, so it looks like I need to go in spot, what's that, 1, 2, 3, 4, 5, 6 to block them. And then I guess I need to take the remaining spot, which is spot 9. All right, and it's a tie. And you're as smart as a computer making random moves. Why am I as smart as a computer making random moves? Well, because actually all that's happening right now is Tic-Tac-Toe is making random moves. So I did literally just tie a computer making random moves. Hopefully I can do better. So if I take the middle spot, the computer chose a random move. And let me pick another spot. I don't know what I don't actually know what the strategy is here. I probably should. 1, 2, 3, 4, 5, 6, 7. I think I'll go 7. No. Yeah, that's fine. I was trying to give myself 2 ways to win, but actually I'm only going to have 1 way to win. So the computer was making random moves, like I said. So they went here 2 and 2, and now the corner's open. I need to block them, but also when I block them, I'm going to have 1, 1, 1. So if I put it in 1 in spot 3, I'm going to win. Uh-oh. I didn't win. Okay. So something bad happened here. So the game isn't over yet, it says, but the game is actually over yet because 1, 1, 1. I should have won the game. So let's fix that. So how are we checking if the game is over? Well, there's a function for that. Check game over, right? So game over, check game over board. So that's how we check in this function. So let's open up check game over and let's fix this. So, oh yeah, here's what we need to do. It says function check game over. Check game over takes a 3x3 matrix to check to see if a player won or if there is a tie. So when we start out, the game over is 0. All right. Now, also something else about the way this works is, hold on, where's the Tic-Tac-Toe game? So when the game is over, game over will store either a 1 or a 2. And what it does is it stores the winner of the game. So when the game is over, if game over is 1, then you won. If game over is 2, then the computer won. And if game over is 3, it's a tie. And then there should no way that anything else could happen, but I added an else. So game over 1 means you win. Game over 2, computer. Game over 3 means tie. So I need to be checking for all of the possible ways to win, right? And so remember, any horizontal, any vertical, or any diagonal is a winning condition. So here's an example of how I'm checking. So if you check spot 1, well, okay, so if spot 1 is not 0, right? So let me go to an editor here. Where's an editor? Here we go. So checking winning. All right, check win condition. So how will there be a win? Where can I put this? Squish it. Okay. So how could you check a winning condition? Well, what does this say? This is a win condition right here. So it says if board spot 1 is not 0. So board spot 1 is not 0. So that means that so far you got like maybe you got a 2 there. So this is checking if the first spot does not have a 0. Then it says if board 1 equals board 2. So first of all, this is not empty, and then the second spot is equal to it. So that would be like a 2 there, for example. And then it says if board 2 is equal to board 3. Well, this would be board 3, right? So if you want to check if positions, if you want to check if positions 1, 2, 3 all match and are non-zero, that's what we're checking. So we need 1, 2, and 3 to be the same, and the top, or one of them basically, it doesn't matter which one, to be non-zero. And that's what we're checking here. So this checks that spots 2 and 3 are equal. This checks that spots 1 and 2 are equal. So together, this much means that 1, 2, and 3 are all equal. But zeros don't count. And so I'm double checking that spot 1 is not a 0. And if that's the case, then whatever number was there, right? Like I drew the board with a 2 there. Then that's the player that won. So if there's a 2 here, player 2 wins. And that's what this line does. Okay? Now, what does this do? The next block, 11 through 13. Well, it's the same thing. If you compare 11 through 13 to 7 through 8, it's the same code. It's just that instead of checking spots 1, 2, and 3, I'm checking spots 4, 5, and 6, right? So that would be checking this. Again, the fact that I used a 1 and not a 2 is not important, right? Just this is 4, 5, and 6. Okay? So I only checked 1, 2, 3, 4, 5, 6. You're going to have to go through and copy paste this for all of the possibilities, right? So like 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We need to check 7, 8, 9. How would we check 7, 8, 9? Well, you just change the numbers in the code here. So I copy pasted it. Now we're not checking 4, 5, 6. We're going to check 7, 8, 9. 7. And then we would need to check if 7 was equal to 8 and if 8 was equal to 9. Now that will check that there's a, how'd I do that? If 7, 8, 9 are equal. All right. But that's not going to be the only 3, right? I think there's 8 winning conditions. You also need to be able to check for like a 1, 1, 1, for example. Or a 2, 2, 2. Point is horizontal. You would need to check for a horizontal winning condition. Well, how would you do that? Well, we did the 3 vertical. Now you need to do the 3 horizontal. Maybe I'll put a comment. Horizontal wins. So it's just the same code, but now you need to think like, well, what positions are those? So remember the numbering, right? The numbering is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is spot 1, this is spot 4, and this is spot 7, right? Because the numbering is the way it is here. So you actually need to check 1, 4, 7 for that. So how would you do that? Well, again, check 1, non-zero, and then 1 should be equal to 4, and then 4 should be equal to 7, and that would be the first horizontal winning condition. So you have to add all of these before your game works. So I saved these, then we go to tic-tac-toe. No, let's run tic-tac-toe. And it still does not know how to check everything, but it knows how to check all the vertical ones. So let's try to get a vertical win here. 4. Aha, it's gonna let me. So 1, 2, 3, 4, 5, 6. So if I put 1 and 6, should win. I win. You win. You must be a tic-tac-toe genius. Am. Um, right? So I've done not all of the winning conditions though. I've done 3 and then 4. There's actually 8 winning conditions. So make sure that you do all 8 winning conditions. 3 horizontal, which are here, 3 vertical, 2 diagonal, 8 winning conditions. So you code those all up. All right, I'm going to stop here for your, as far as that goes. So that is your let's what was I gonna say? You do all that, and then your tic-tac-toe game works. Okay. Now I think I am actually going to stop this lecture here. You should make all of the winning conditions work. What we're going to do next time is we're actually going to talk about the CPU moves. What you'll see about the CPU moves is there's 3 functions. There's CPU move, CPU move random, and CPU move smart. So the way I coded this up is as follows here. We'll explain this at the beginning of the next video as well. But the idea is, here's how it works. Well, pause. It waits 5.5 seconds just because. So here's what it does. It tries to call the smart function. And then if the smart function returned a bad move, then it does a random move. So like CPU move random is a fallback. It'll make a random move if there is no smart move. And that's why I'm actually able to play the game here. Because even though there is no smart logic yet, the CPU can still just pick random numbers for the moves. And that's what it's doing right now. So it tries to do a smart move, and if that fails, it does a random move. So you don't need to touch CPU move random because it already does that. Yeah. So all it does is generate random numbers, basically. So yeah, we'll talk about how to make smart moves in the next lecture. That's it for this. I'll talk to you guys later.